Last May, a group of BYU engineering students touched down at the airport in Quito, Ecuador, excited and a little nervous. They were headed to a small prosthetics clinic at the base of a volcano for what felt like the ultimate final exam. For 2 semesters, they'd been designing and redesigning 2 key components for prosthetic legs, liners and foot shells. Their goal was to make components that were affordable and comfortable, and that could be manufactured locally to avoid import costs. But it's one thing to test products in a classroom, and quite another to let actual patients try them out. Here's Cody Messick, a mechanical engineer who worked on the footshell team.
One of the patients came in with a footshell that was absolutely tattered. I mean, it was duct taped together and it was basically worn to dust. And we were talking to him about what he does, and he sells gum and trash bags on the side of the road and makes about $5 per day, and has a family of 2 little girls to support with his disability. And so it becomes almost impossible for him to save up enough money to receive a footshell. And he put it on and he was walking around on it, and he just really loved the way that it looked. He said it looked really cool and he was excited to show it off. And he said that it felt like he had his own foot again, which was, it's such a rewarding thing to hear.
Welcome to the Why Magazine podcast, bringing you ideas, stories, and voices from Brigham Young University. This is Whitney Archibald, and today we're going to talk about how this prosthetics project came to be and about the creative solutions these engineering students came up with to help patients at this clinic. This episode is based on the article Making Strides in the fall 2023 issue of Why Magazine by Michael Walker, who actually joined the team on their trip. You can find this article plus a video about the trip at magazine.byu.edu. The Ecuador Prosthetics project started with a prompting. Joshua Frei was a chemical engineering student at BYU.
I was watching a video that the church put out about a gentleman who had lost part of his foot in Afghanistan. And I just remember feeling, as I watched that video, this compassion for him and for anyone else who struggles with limb loss. And I just felt this powerful impression that I should go into prosthetics. And I didn't know what that meant at the time. Does that mean I do it as a hobby, as a career, as an engineer, as a healthcare provider? Like, what does that mean? And so I went on this really long journey to try and understand what exactly God's plan was for me about going into prosthetics. So I did a little bit of research and found out that BYU has a prosthetics club.
So Josh joined the prosthetics club and soon became the club president. In the meantime, he also got involved with the Global Engineering Outreach Program at BYU, also known as GEO. GEO is a 2-semester class where all types of engineers, manufacturing, mechanical, chemical, civil, work together on real-world humanitarian projects. Engineering students have to apply to be part of the GEO class, and 20 to 22 students are selected each year. Here's chemical engineering professor Randy Lewis, who teaches the course along with mechanical engineer Terry Bateman.
Unlike a lot of typical coursework that students do, they tend to do book work that are either pretend questions, or they might be a project that they don't build, but maybe they do it on paper. We want them to actually get hands-on, real-world experience on projects that are of impactful nature in these developing communities. So that first year we did a project in Tonga, working on biodiesel from coconuts. And it's just gone from there to primarily focusing in South America now. And since 2007, we've had multiple hundreds of students that have been in the class.
Joshua Frei took the GEO class in 2017 and enjoyed it so much he became a teaching assistant for the class the next year. He proposed to Lewis and Bateman that they add a prosthetics project to the list.
And they said, all right, Kate, you scope something out, find it for us, and we'll give it a shot.
So he did. He found a clinic in Ecuador called Prótesis Imbabura in Ibarra, Ecuador. It was founded by Bob and Kit Frank, therapists and philanthropists from North Carolina who have volunteered in Ecuador for decades.
They said, well, we have this idea of what if we could manufacture our own prosthetic liners. They're super expensive. They're really hard to source. That's one of the big issues in Latin America with getting equipment, is because there's limited fabrication sites and not a great supply chain. So it's hard to distribute all of the goods, and it's really expensive. And so if they could manufacture their own, it would help them see a lot more patients and make the cost of care significantly less expensive. So out of all the projects I had considered and looked at, this one really seemed to have the highest potential for impact and the highest feasibility. And so I took it to Randy and Terry and said, here you go. This is my project idea, and pitched it to them, and they bought in.
The next year, in 2019, a team of GEO students tackled the challenge of creating a liner for prosthetic legs. This is a protective sleeve that goes in between the patient's skin and the prosthetic. The challenge was to create a liner that was comfortable and inexpensive.
The first year, the students were basically, how do we even make a liner? What material do we use, et cetera, et cetera. And so that first year, they were able to make a liner out of silicone. But the issue was the liner wasn't always the same thickness. The mold that we made it from had a few challenges. So the next year's team developed a new mold that was 3D printed. We were able to get more consistency on the liner thickness and so forth. And so it wasn't until after those first few rounds before we were actually able to bring liners down to Ecuador and try them on patients.
Last year's GEO class, 2022 to 2023, included 4 teams, each working to solve a distinct problem. One team worked to design efficient and reliable water pumps for families living in the Uros Islands in Peru. One team designed an automated process for families in Bolivia to wash the bitter and slightly toxic layer of quinoa seeds from their harvest, typically a time-consuming process done by hand. Another project is a low-cost sensor to measure CO, CO2, and particulates from indoor wood-burning stoves inside homes in Peru and Bolivia. And one team once again tackled the prosthetic liner project to continue improving the design and the manufacturing process. This time, though, the GEO program also teamed up with an engineering capstone class to form another prosthetic team to design another consumable part for prosthetic legs, the foot shell. We're going to dig into both prosthetic projects with a student from each team to explain how they designed their solutions. We'll start with Anya Jeppsen, a mechanical engineering student. Anya was very excited to be selected for the liner team because it meant she would get to return to Ecuador. She had served 4.5 months of her mission in Ecuador before being reassigned to Layton, Utah because of COVID restrictions. This would give her another chance to serve the people she'd grown to love during her short stay in the country.
When our plane landed in the Quito airport, I started tearing up a little bit just looking out the window. It was so awesome to be back there.
The liner team included 2 other mechanical engineers, 1 manufacturing engineer, and a chemical engineer.
That was really cool to learn from the manufacturing engineering student's experience with actually using the machines. So the chemical engineering student, he was very valuable in trying to figure out the properties of the silicone.
This is true for all GEO teams. Each one is made up of at least 3 different types of engineers. The team worked together to improve the design from the previous year's team based on feedback the team got from their trip to the clinic.
Some of the challenges were materials. We had issues with making sure that the surface of the liner wasn't too sticky with the silicone we were using, and also reliability. This is an ongoing project, so there was a team that was working on this in previous years, and they had issues with sometimes their silicone would tear and sometimes it wouldn't. It was like every other time, like they would open up the mold and it would just be this mess of silicone that just didn't cure right. So that was a big issue that we came in and tried to solve right off the bat. And so one way that we resolved that was using a different material for the mold itself. And that kind of gave the design a lot more flexibility. We could change the sizes of the mold much easier. And then also, we didn't have any issues with the silicone not curing, which was great.
As they worked through these challenges, Professors Lewis and Bateman encouraged them to seek and recognize inspiration.
We call this inspired learning, and we actually asked the students to give a weekly report on things that they do. And part of that report, we say, was there something inspirational that happened this week that helped move your project forward? And that inspiration could have been anything from an impression from a prayer, or it could have been they ran into someone unexpectedly, whatever it might be. And not everyone has something every week, and we're not expecting something every week. But it's amazing to see some of the stories and some of the things that have happened. So like the silicon, for instance, how do you get 2 pieces of silicon to stick together? And they get some inspirational ideas that they try and it works. And so It's not really one event. It's just
Right.
lots of little pieces here and there that make it all work.
The professors add their ideas once in a while, but mostly they leave it up to the students.
We like to have them look at us as kind of cohorts and members of their team. So I actually have them call us by first name because we want them to feel like it's a real working environment, like what you would experience out in a company. And we look at ourselves as more like mentors for the teams. We want to just give them insights and direction, and then our experience working in those countries is helpful. And the really cool thing is, during the year, because it's not like a typical class where you know the answer, you don't know the answer. And initially that's frustrating to the students because they're used to there's an answer. And when there's not an answer, it's a little frustrating, but they learn how to deal with that. And sometimes as we get closer to the implementation trip, it's like, we don't know how this is going to work because we're not ready to go yet. But it always comes and works right before the trip. Sometimes it's just the day before, but it all just comes together. And it gives them faith and hope in the things that they're doing, and gives them insights of perhaps in their personal life or in their career in the future. They can see that things don't always just happen. You need to have faith and work, and then things will come together eventually.
The footshell team was a little different. Although they worked closely with the GEO students, they didn't meet during the same class period. They were part of an engineering capstone class. When manufacturing engineer Cody Messick got an email about this new humanitarian capstone project, he was enthusiastic, to say the least.
I literally ran to the capstone office and I was like, how do I join this capstone project? Because it has to do with like biomechanics and it has to do with humanitarian work. And those are the two things that I really I would love to be a part of. And so they were like, well, we haven't even sent out the survey, but you can be our first test subject, I suppose. And so I filled out the survey and then I ran over to the lady, one of the professors that was in charge of recruiting the students to make the teams. I tried everything that I could to find a spot on that BYU capstone team.
Well, of course, Cody did make it on the footshell team. By now you might be wondering, what exactly is a footshell? Basically, it's a soft, foot-shaped piece that goes over the prosthetic foot, which is usually made of carbon fiber, but sometimes also wood, metal, or plastic.
So the carbon fiber part provides all the dynamic movement and structure and stability, but the footshell provides the aesthetic of a foot and it prevents the carbon fiber from wear and tear and is able to fit into a shoe as well, because that's really important for our patients.
Unlike the liner project, this footshell project was new last year, so they were starting from scratch.
We came into the project and had nothing to start with, which was really fun, honestly. We really loved coming up with all the ideas. And we went through a lot of different ideas for how to make this prosthetic part, the footshell. We went from like maybe having a mold that you slosh around with a fast setting type of rubber, and you would like slosh around and get really messy, but you'd have a thin outside wall to, we tried even melting out wax out of the inside. There's a lot of different prototypes, but we got started right away, got our hands dirty within the first couple of weeks and just tried everything. For the model itself and the shape, I did a lot of that work with the computer-aided design and coming up with the shape of the footshell, and that took a lot of work as well. At that point, the options we came to was almost imagine a Lego type inside mold where you have multiple pieces that are held together by magnets, by really strong magnets. So when you put it into the outside mold, this inside mold stays as one unit. And then you pour the material that we used around the outside space to create the footshell shape. Once it sets, to get the inside mold out, you pull on these ribbons, which are attached to each individual piece, and they pop out, each little piece at a time.
That is genius.
I spent a lot of time making sure that each little piece would pop out easily enough. And so I had to change the shape so that it would slide out of the cavity without too much pulling, because then it would damage the molds and you'd have problems with making new molds all the time. So it was a process to get the right geometry, but that actually ended up working exceptionally well.
The students created molds and foot shells in several different sizes to bring down to Ecuador, but more importantly, they provided the tools for staff members of the prosthetics clinic to create them themselves.
We gave them all of the instructions for how to make all of the molds in the manufacturing process, but we also gave them instructions and all the stuff they needed to make their own foot shells with the molds we gave them. And if one of the molds breaks down, or if they need a new mold because they need to increase the rate of their production, they have instructions they can follow to then make that new mold. And it uses 3D printing to make it, because that's something that they have available to them with the local university. And so we made sure that all the files were very translatable so that they could essentially print those if they needed to.
Once the students got to the clinic in Ecuador, they spent their time testing the liners and foot shells with patients and teaching the staff at the clinic to make the components.
They were really happy about it, especially like the pulling the little pieces out of the foot shell. They thought that was really fun. And we had ribbons that were all these different colors, one for each part. And so they really enjoyed pulling them out, and they just thought it was a fun process that they were really impressed, especially with the consistency and the quality of the foot shell. They kept, inspecting it and playing around with it, and they were like, wow, this is better than some of the ones that we've bought. So
awesome.
They were really happy with the quality as well as the repeatability of it. I mean, it's quite simple. It takes them about 20 minutes to go through the whole process and make a foot shell or two.
The liner team also got good feedback from staff and patients. Anya remembers one patient in particular.
Overall, he said it was very comfortable, and he liked it. He walked around in it, and he said that it was a great design. So in the future, we can use this information from him and from other patients to really make the design better. And I just get so thrilled to hear them say that they find it more comfortable than the ones they have been using in the past with the commercial liners.
The GEO class of 2023-24 is continuing work with the prosthetics, quinoa, and cook stove projects, but have also added a team to create adaptable wheelchair cushions in Ecuador. The prosthetics team is using what last year's team learned from their visit to Ecuador to continue to improve the liners and foot shells and the processes used to make them.
We don't want students to come down saying, hey, we've got the solution and we're the only ones that know what to do, and you're going to take our solution and life's going to be great. We want this to be a cross-cultural thing. Like, our students learn from them, they learn from us, and realizing that all sides can contribute.
Lewis and Bateman are also working on involving students and faculty from other disciplines on campus, including nursing, sociology, and business. They're also increasing the number of times they visit these countries throughout the year. Although he graduated before getting to go to Ecuador himself, Joshua Frei is thrilled about how well the project has turned out. Plus, he still has a personal stake in the project.
Yeah, well, one of the things I've loved about this is 2 of my sisters now have been able to work on this project. And I never would have thought that this would just keep going even after I left. And then my younger sisters, who are also engineers, would be spending their time developing it.
For Cody,
I think what surprised me the most was how the education that I received at BYU that taught me how to solve problems that are incredibly relevant to people that don't have the resources or connections to solve those problems themselves at this time. And I thought that was really humbling that I could choose to continue to do this going throughout my life.
This transformation for the students is what Lewis loves most about the program.
To me, that's what it's really about, is helping them to see the bigger picture of why are they at BYU, what is their purpose, and what are they hoping to learn and to grow as they go out once they graduate.
Thank you for listening to the Y Magazine podcast. If you enjoyed it, share it with your friends and family. This episode is based on the article Making Strides by Michael Walker in the fall 2023 issue of Y Magazine. It was produced by me, Whitney Archibald. Executive producer Denya Palmer. Sound design and original music by Jarrett Davis.